Okay, what I'm holding in my hand is a Phantom 4 drone from DJI. One of the challenges we have as coastal geomorphologists is getting data collection. Many reasons. Data is expensive. There's logistics in terms of how much time you can commit to fieldwork when you have other obligations in universities. So some of the primary data we collect is survey data, and traditionally that whole area of technology has evolved over decades, and especially the last couple of years. The standard go-to instrument is GPS, specifically differential GPS. That gives you the centimeter scale accuracy that's required for a lot of the work we do in geomorphology. Unfortunately, for example, in the Maharees project that I'm working on down here, we have a 1.2 kilometer stretch of coastline that we're examining, the beach dune dynamics. So to survey that 1.2 kilometer stretch, we have to survey the beach elevation, the vegetation line, the shoreline, which is where the dune is, and that takes approximately 2 full days surveying of one person surveying for a full day. So 2 8-hour days, so that's 16 hours of surveying, up to 1,000 GPS points. And so at the end of the day, we transfer all those points, those elevation points, they give you X, Y, Z. So it's X, Y is latitude, longitude, position, and the Z is elevation. So each point from a GPS gives you 3 points, and we transfer that information into a GIS, Geographic Information System, and we produce 3D digital elevation models. Now, recently, the whole technology of unmanned aerial vehicles are what most people call drones. These are actually technically, the Phantom 4 here is called SUAV, a small unmanned aerial vehicle. It can be simply controlled by a controller, and what it has is 4 propellers and a standard GoPro type camera. Basically what we use this Phantom 4 for is surveying sections of the beach here in the Maharees, and it provides us it basically provides us an extra surveying technique on top of the GPS. Is you can build orthophotographs from the data that essentially we fly a certain path line here, and we do repeat surveys every month, and which means that the same flight is done every month, and from these flights we stitch the photographs together. So as the UAV is following the flight plan, it takes a photograph essentially to make sure that there's 80% overlap in each photograph. We use specific customized software called AgiSoft that stitches the photographs together, and then what we do is we incorporate ground control points on the survey to actually create an orthophotograph. So what the UAV does is it flies a designed flight plan that we plan beforehand. So each month the same flight is done. We use customized software that stitches all those photographs together. We incorporate ground control points from the GPS that essentially helps us rectify the images, and the final product becomes an orthophotograph, which is georeference. That is not only contains the position of each point, but also an elevation. And from that we can do lots of analysis including what's the change in elevation of the beach from one month to the next, what's the change in shoreline position from one month to the next. And so cumulatively we aggregate all these data each month together to get a picture of what this section of beach dune is doing. So that's why the Phantom 4s are now becoming part of our arsenal in terms of understanding the dynamics of how beach dunes operate.
I wonder what the seagull thinks about it.
Not happy. Lots of advantages to this in terms of you can get very detailed coverage of a small area. A couple of disadvantages, some of which can be overcome. The battery life is 20 minutes, so it's important to have backup batteries. More importantly, in terms of the work we do, it doesn't just extend from the dune to the beach, but we're also interested in the near shore, because that's where a lot of the sediment is kept that basically is moved back on if nearshore bars become welded to the beach. So the GoPro camera at the moment cannot penetrate vegetation or water. So we're really confined to terrestrial land cover that has, we would hope, some good texture that's picked up by the camera. So the next step up for us is to have cameras that actually can penetrate water, so we can get the local bathymetry, preferably to 10-meter depths. Similarly, we want cameras, either they be multispectral or hyperspectral cameras on these UAVs that can penetrate vegetation, so we get the ground cover. Because as we know, a lot of the sediment is blown into these dunes and the ground elevation accretes and the vegetation comes with it. Now we want to know these changes over time. So the next step up is the payload of the Phantom 4 is 350 grams, so it can only contain a small camera. The hyperspectral, multispectral type cameras are larger, which means we need a larger UAV. So that's the next step up. But with that equipment, it means we can not only monitor the beach dune, but we can also monitor changes in the near shore. And we're very interested in bar migration and how the sediment, that when we can't see it right now if it's covered with water, we can actually get the local bathymetry. The advantage of that is logistically, to get local bathymetry in the near shore requires very specific rafts with small drafts and the echo sound equipment. Trying to get the near shore bathymetry is very, very difficult. Some of our bays have been done by Infomar when they've done priority bays and they've done some shallow water bathymetry, but that requires rafts. Again, needs planning a year in advance. So hopefully, as the costs come down and the technology, off-the-shelf technology, drone technology or UAV technology becomes available, then our job as coastal geomorphologists will become easier.